You tap an icon on your phone, a website pops up, software crunches data. It all just works, right? Most of the time anyway.
Delightfully.
But have you ever given a thought to the behind-the-scenes work that makes that seamless experience possible?
Probably not something most people think about daily.
Right. So today we're taking a fascinating dive into software testing, that crucial but often invisible part of the tech world.
Absolutely vital.
Our mission, to get a clear understanding of two foundational approaches, black box and white box testing.
The big two.
Think of this as your shortcut to grasping their core differences, what each brings to the table, and where they might fall short.
Good plan.
Ever wonder how developers actually make sure the apps and programs you rely on don't just break all the time? Well, today we're pulling back the curtain on a key part of that story.
It's quite remarkable when you consider it, this whole process of ensuring software quality. And yeah, at the heart of it, you have this fundamental fork in the road represented by black box and white box testing. The crucial difference really boils down to whether the person doing the testing has any knowledge of what's going on inside the software.
Inside the box, so to speak.
Exactly. With black box testing, it's as if you're looking at a sealed box. You interact with the outside, the user interface, maybe, but you have no clue about the code or internal workings.
Okay, makes sense.
White box testing, on the other hand, is all about opening that box. Testers have complete access to the code, the structure, the implementation details, everything.
Okay, this sealed box idea makes sense. So if we're in black box mode, we don't need to be fluent in, like, Python or Java or whatever.
Precisely. That's a key differentiator. Black box testing doesn't require any programming knowledge whatsoever.
Really? None at all?
Well, not to perform the core testing. It's often carried out from the perspective of someone using the software, just like you would clicking buttons, entering data, seeing what happens. The focus is entirely on what the software does from the user standpoint. Now flip to white box testing, and you absolutely need programming chops. Testers need to understand the code to analyze its structure, spot potential weaknesses, and design really targeted tests. You're looking inside.
Here's where it gets really interesting. If black box is all about the user's experience, what the software achieves, what's the driving force behind white box testing? What's its main goal?
Yeah, the objectives are quite distinct. The main aim of black box testing is to evaluate the software's behavior. Does it meet the initial requirements? Does it perform its intended functions correctly from the user's perspective? Does it do what it's supposed to do?
Okay, function and behavior.
White box testing, however, drills down into the internal operation of the system. It's about scrutinizing the code itself, ensuring all its components are functioning correctly, and identifying any hidden flaws in the way it's been built, how it works inside.
Right, so it's like testing a new video game by just playing it. Does it work? Is it fun? That's black box. Whereas white box is like going into the game's code to make sure all the rules and calculations are programmed correctly, like checking the physics engine.
That's a spot-on analogy, yeah. And this difference in viewpoint naturally leads to different kinds of reports you get out of it.
Oh, how so?
Black box testing usually gives us what we call low granularity reports. These are high-level summaries, essentially saying whether a feature passed or failed from a user's perspective. Pretty broad strokes.
Pass-fail. Got it.
White box testing, because it dives into the code, generates high granularity reports. These reports can pinpoint specific lines of code that were tested, the outcomes of different code branches, providing developers with very detailed information for fixing any issues. Much more detail.
And with all that digging into the code, looking at branches and lines, it must take a fair bit longer, right?
Oh, absolutely. Yeah. When we compare the time involved, black box testing is generally less time-consuming.
Generally?
Generally, yes. Because you're not doing that deep code analysis, you can often design and run tests more quickly, particularly for the main features. White box testing, with its detailed examination of the code and the need to cover various scenarios within it, well, it's a much more thorough and therefore usually more time-consuming process.
Now, where do these two types of testing typically fit into the whole software creation journey? Are they done at the same time?
Good question. No, they often fit in at different stages. Black box testing often comes into play at the later stages.
Later, like near the end.
Yeah. For example, in system testing, where the entire finished software is evaluated as a whole, and also in acceptance testing, where the end users themselves test it to make sure it meets their actual needs, closer to release.
Okay. And white box?
White box testing, focusing on the inner workings, is usually applied earlier on.
Earlier? How early?
In unit testing, where individual parts of the code, like small functions or modules, are tested in isolation, and also in integration testing, where groups of these individual parts are tested together to see if they work correctly when combined, much closer to the coding process itself.
Interesting how they have their own sort of sweet spots in the development timeline. And I get the feeling these aren't the only terms people use for them. People love jargon, right?
You're right, they definitely have aliases. Black box testing has several other names, like data-driven testing,
Why data-driven?
because it focuses on the data you put in and the results you get out without looking at the code.
Yeah.
Makes sense, yeah.
Yeah, okay.
You might also hear it called box testing or functional testing, again, emphasizing the focus on what the software does functionally.
Functional testing.
Okay.
What about white box?
White box testing is also known as structural testing.
Because structure.
Exactly, because it examines the software's internal structure. Also, clear box testing, highlighting the transparency, or code-based testing, obviously. Or even glass box testing, again, with that idea of being able to see right through it.
Glass box, clear box. I like those. So what actually kicks off each of these testing processes? What's the initial trigger? Like when do they say, okay, start testing?
Well, black box testing typically begins once the requirement specification document is ready.
What it should do, Doc.
Precisely. This document outlines what the software is intended to do, functionally, and black box testers use it as their roadmap to verify if those intentions are met from a user's perspective.
Okay.
White box testing, on the other hand, usually gets going after the detailed design document has been prepared.
The how it should be built, Doc.
You got it. Think of this as the blueprint for how the software will be built, providing the necessary internal information for white box testers to analyze the code structure and create their tests.
So requirements trigger black box, detailed design triggers white box.
Got it. And who are the typical players involved? Is it the same people doing both?
Not always. Black box testing often involves a range of people, including the actual end users who can provide feedback on how usable the software is. Real people.
Yeah, real people. Also, developers who might do some initial high-level checks of the functionality, and dedicated testers who specialize in evaluating software from that external, user-focused perspective.
Okay, a mix. And white box, more specialized.
Generally, yes. White box testing is primarily the domain of testers and developers who possess the necessary programming skills to understand and analyze the code base. You need to be able to read the code, essentially.
Makes sense. Okay, so how do they actually do the testing in each case? What are the main approaches or methods they use? Like, what does it look like day to day?
Right. Well, black box testing often relies on a bit of trial and error, where testers will try different inputs and see if the outputs match what's expected.
Poke it and see what happens.
Kinda, yeah. They also focus heavily on analyzing data domains, the different types of data the software handles, and especially boundary conditions.
Boundary conditions, what are those?
Those are the values right at the edges of acceptable ranges. Like, if a field accepts numbers from 1 to 100, they'll test 0, 1, 100, and 101. These edge cases are often where issues crop up.
Ah, okay. Stressing the limits.
Exactly. White box testing, in contrast, is all about code coverage.
Code coverage.
Yeah, this means ensuring that different parts of the code are actually executed during testing. Key types of coverage include statement coverage,
Which is?
aiming to run every single line of code at least once to catch basic errors. Then there's branch coverage.
Branches.
Yeah.
Like if statement.
Exactly. Branch coverage makes sure every possible outcome of a decision in the code, like an if this, else that, is tested. And then path coverage.
Okay, another one.
Yeah, path coverage is even more detailed. It tries to test all the different routes the program logic can take as it runs, which can get really complex really fast.
Wow, okay. It sounds like white box testing is much better suited for really getting down to the nuts and bolts of algorithms, wouldn't you agree? Like hacking the core logic.
Oh, absolutely. Definitely. Because white box testing gives you that deep understanding of the code's logic and structure. It's the preferred method for testing algorithms, where you need to verify the correctness and sometimes the efficiency of the underlying calculations.
Right.
Black box testing, without that internal view, isn't really designed for that kind of thorough algorithm scrutiny. You're just seeing the result, not how it got there.
And a really fundamental difference, as we touched on earlier, is having access to the actual code itself. That seems huge.
That's a critical point. Yeah, maybe the critical point. Black box testing doesn't require any access to the source code whatsoever.
None.
Nope. Testers interact with the software purely through its user interface, or maybe its APIs, just as a regular user or another system would.
Okay.
White box testing, however, absolutely necessitates having access to the code. That's the whole point, really.
Right.
This allows testers to examine it, understand how it's put together, and design tests that target specific parts of the implementation.
And that must have implications, like for security.
Hmm.
If you let someone else see your code.
That's a very important point, yes. If you're outsourcing white box testing, you're essentially giving an external party the keys to the kingdom, access to your code base, your intellectual property. That needs very careful consideration and strong agreements in place.
Yeah, I bet. Okay, let's unpack this. What are the big wins for each of these testing styles? What are the key benefits? Why do both?
Okay, let's think about what each brings to the table. Black box testing is particularly good for testing large chunks of code or even entire systems.
Efficient for big stuff?
Can be, yeah. Because it's focused on the functionality from the user's perspective, it can quickly highlight major usability problems and whether the software actually does what it's supposed to do according to those initial requirements, the document that says what the software should achieve.
User-focused validation.
Okay. White box testing, on the other hand, offers the advantage of being able to identify and remove extra or redundant bits of code, dead code, basically, which can sometimes lead to hidden errors or just slow things down.
Cleaning up the internals.
Exactly. And by looking closely at the code, testers can also uncover logical errors and ensure that all the internal components are working correctly as per that detailed design document, the blueprint, remember? Finding bugs deep inside that a user might never trigger directly or not for a long time.
So one checks the what, the other checks the how, sort of.
That's a pretty good way to put it, yeah.
And when it comes to the folks doing the testing, we talked about skills.
Yeah.
What kind of skill set do you really need for each? Is it a big gap?
It can be, yeah. As we discussed earlier, black box testing can be effectively carried out by testers who might have a more general understanding of software use, maybe strong domain knowledge for the application. They don't necessarily need to be coding experts to evaluate whether the software's features are working as expected.
Lower barrier to entry, maybe?
Often, yes. However, white box testing really requires expert testers who have significant experience and a solid grasp of programming principles, code structures, maybe even specific languages or frameworks, to be able to analyze the code effectively and create comprehensive test scenarios. It's definitely more specialized.
Right, you need the code experts for the code testing. Makes sense. Can you give us some concrete examples of the specific techniques they use in each approach? You mentioned a few.
Absolutely. So in black box testing, you'll often see techniques like equivalence partitioning.
Equivalence partitioning.
Okay, what's that?
That's where you divide all possible inputs into groups or partitions that are likely to be treated the same way by the software. Then you just test one representative value from each group instead of testing everything. Saves time.
Smart. Like testing one positive number, one negative, one zero.
Kind of like that, yeah.
Yeah.
Another common one is boundary value analysis, which we touched on.
Yeah, testing the edges. Exactly. Focusing on testing the values right at the edges of those input ranges, plus just outside them, as that's often where errors tend to occur.
Got it. And for white box?
For white box testing, as we mentioned, the key techniques revolve around code coverage. So you have statement coverage.
Every line runs once.
Making sure every line of code gets executed. Then branch coverage.
Testing the ifs and elses.
Testing all the possible outcomes of those if and else decisions in the code. And path coverage.
All the possible routes through the logic.
Trying to test all the different logical routes the software can take as it runs. Which, again, can be very hard to achieve 100% in complex software, but you aim for high coverage.
Okay, those sound pretty distinct.
Yeah.
And what about the downsides? Are there any limitations or weaknesses to either of these methods? Nothing's perfect, right?
No. Definitely not. Both have their limitations. One challenge with black box testing is that if the software application, especially the user interface, is updated frequently, any automated test scripts that were created might break easily and need a lot of reworking to stay effective. They can be brittle.
So maintenance can be an issue.
It can, yeah. Also, because you're not looking at the code itself, you might miss errors in parts of the system that aren't directly exercised by the specified requirements or the common user paths.
Hitting stuff.
Okay. And white box drawbacks.
With white box testing, a significant drawback is, similarly, that if the underlying code changes rapidly, those carefully crafted automated tests that were designed for the old code structure might become completely useless.
Also brittle in a different way.
Exactly. They require a lot of effort to update and maintain them alongside the code. Plus, even with very thorough white box testing, as I mentioned, It can be a real challenge, sometimes practically impossible, to test every single possible pass through complex code. You might still miss things.
So neither one is a silver bullet on its own.
Definitely not. They're complementary.
Thinking about all the apps and software we use every single day, I mean, it's everywhere.
Mm-hmm.
Can you see how both of these different ways of testing might be essential for making sure we have a reliable experience? It feels like you need both.
Oh, absolutely. You really do. Black box testing is crucial for ensuring that the software meets the user's needs and behaves as expected from the outside. It gives us that vital perspective on usability and overall functionality. Does it actually do the job for the user?
Right, the user view.
And white box testing complements this perfectly by making sure the underlying code is robust, efficient, and of good quality, catching errors and potential issues that might not be obvious just by using the software, or might only show up under weird conditions.
Finding the problems under the surface.
Exactly. Both really are indispensable for building high-quality, dependable software that people can trust.
So, to kind of bring it all together, it's clear that both black box and white box testing are absolute vital.
Yeah.
But they tackle the challenge of software quality from fundamentally different angles.
Precisely. They look at the problem through different lenses, and understanding these core differences, it gives you a really valuable insight into just how complex it is to create the reliable technology that we all depend on, sometimes without even thinking about it in our daily lives.
Yeah, definitely makes you appreciate it more. And as software becomes even more deeply woven into practically every aspect of how we live, I mean, cars, homes, finance, everything, it really makes you think. How might the balance between these testing approaches and maybe the specific techniques they use, how might that continue to evolve to meet the ever-growing demands, the new challenges of ensuring that the technology we rely on truly works?
That's a great question. The complexity isn't going down, that's for sure.
No kidding. It's definitely food for thought.
Right.
You know, all that unseen effort that goes into making our digital world function, hopefully, most of the time.